Hey guys, I'm Chris Harrison and we're back on ABC for another Monday night premiere of the Math Bachelorette. This is going to be the most dramatic season to date. We've condensed it to 3 guys going for the hearts of the famous Elena Toteva. So tune in.
The Bachelorette season premiere Monday, May 14th on ABC.
So this is our Bachelorette, Elena, and how are you feeling about tonight?
You know, I'm just ready to find love, finally. It's been a long journey.
Yes. Yeah, we got 3 amazing guys waiting for you. You ready to get the journey started?
I couldn't be more excited.
Hey, it's nice to meet you. I'm Unit Circle.
Hey.
Nice to see you. I'm really excited to start this journey. I got a lot of radians for you to learn about.
You know, I'm looking forward to it.
Okay.
You can never have too many radiance.
Yes. See you in the house. All right, so how are you feeling about the first guy, Unit Circle?
You know, I'm not really feeling the real spark, the connection that I would have expected, but it's the first guy. You never know what could happen.
They ask you how you are, and you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
Hey, nice to meet you. I'm Logarithms, you know, but you can call me Log for short.
Hey.
Not a big deal. So, yeah, you looking good tonight. Yeah, see you later. All right, so how are we feeling about Log?
You know, all I'm gonna say is that Unit Circle's looking pretty good right about now.
Country boy, I love you.
Hi, nice to meet you. My name is Parabolic Function. You look so beautiful tonight. Wow.
Thank you.
I can't wait to get to know you, and yeah.
I'm really looking forward to this.
Me too. So how are you feeling about Mr. Parabolic Function?
You know, I wasn't really optimistic going into this, but after meeting him, I really think we found something. So I'm really curious. I want to get to know you better.
Yeah, so I'm Parabolic Function. I have my parent function, and then I have I like to move all around. I like to translate left, right, up, down. I like to shrink. I like to grow. You know, just I don't like to stay the same too much. You know.
I totally respect that. I'm really excited to get to know all the sides of you.
Yeah, so we can definitely do some more research on me so that you get to know me a little bit better, and because I really think that we might have something.
I think it's important to delve deeper into this.
I think so too.
I'll be back with some more knowledge. Today we're going to be looking at translations and transformations of parabolic functions, which is indicated by f of x equals x squared. This is the most simple parabolic function or quadratic function that is possible because no changes have been made to it yet, and it's just a parabola that goes through the vertex 0, 0 and the point 1, 1 and negative 1, 1. This parent function is going to be translated up, down, sideways, and transformed in all different ways throughout the video. Throughout the video, the parent function is going to be referred to as f of x, and all functions created from that will be referred to as g of x. We're going to start by looking at vertical translations of parent function f of x equals x squared. In this whole section, we are going to be adding, subtracting, or multiplying the entirety of f of x equals x squared to create g of x. The first translation is a translation of 1 up. In function notation, this looks like f of x plus 1, and written out under that is the equation of the new graph. Essentially, we are just moving the vertex of f of x up 1 to create g of x. The parent function in its graph will remain written so that the translations are apparent. It is important to notice that we are adding the whole function and not just x. Next, we are translating f of x down 1 to create g of x. These are referred to as translations because they do not change the shape of the graph, they only change its position on the xy plane. The new graph drawn is that of g of x equals x squared minus 1. Moving on to transformations. These are changes to the parent function that alter its shape. First, we perform a vertical stretch by multiplying f of x by 2 to make g of x equals 2x squared. This makes the graph skinnier because for every x, the y is twice as great as it was before. Now, if we multiply f of x by 1/2 or divide it by 2, we perform a vertical shrink. For every x, the y is half what it used to be, elongating the graph and making it wider. This is the graph of g of x equals 1/2 x squared, or x squared over 2. The last vertical transformation we're going to do is a reflection over the x-axis. By multiplying f of x by -1, the signs of all the y values flip, sending the graph over the x-axis. This is the graph of g of x equals -x squared. Moving on now to horizontal transformations and translations. They are a little less straightforward than the vertical ones. Instead of adding, subtracting, or multiplying the entirety of f of x, we will only be changing x, shown by the parentheses. A good way to remember this is to note that the x-axis runs horizontally and we are only messing with the x. In this first translation, we are adding 1 to x to create the graph of g of x equals, in parentheses, x plus 1 squared. The vertex of this graph moves 1 unit to the left. Do not get messed up with the fact that plus 1 sends the vertex from 0, 0 to -1, 0. The same is true for the next translation of f of x equals x squared to g of x equals x minus 1, all in parentheses, squared. This is a translation of 1 unit to the right, even though it is -1 and takes the vertex to 0, positive 1. Next are the horizontal transformations. By multiplying just the x by 2, we perform a horizontal shrink. Even though we are multiplying by 2, the horizontal shrink is said to be by 1/2, because for every y value, the x is half of what it was. This makes the graph skinnier. This is the graph of g of x equals 2x squared. A horizontal stretch by 2 is achieved by multiplying x by 1/2 or dividing it by 2 and creating the graph g of x equals 1/2 x squared, or x over 2 squared. For every y, x is twice as big, making the graph wider. Finally, we have a reflection over the y-axis. By multiplying all the x's by -1, all of their signs change and the graph is mirrored over the y-axis. Because of this parabolic shape, the transformation is not evident as it already covers both sides of the y-axis, but it becomes more apparent if done to a cubic function which has a different shape.
There's moments like this where I'm holding your hand, and I'm looking in your eyes, and I know I'm so unbelievably